The way we're going to do that is we're going to look at factors of this number that combine to this one. So I like to just start writing out all of the factors of my third number there. So 16 is going to be 1 times 16, 2 times 8, and 4 times 4. Now what I'm looking for is which of those pairs, 1, 16, 2, 8, 4, 4, which ones combine to make 10? Which one? You can either add or subtract, however you need to get there, but which one does it? So 1 and 16 makes either 17 or 15. 2 and 8 makes either 6 or 10, so that's what we're looking for. And then 4 and 4 make 8 and 0, but that's what we're looking for. So there's always going to be an a. We got to split up our a's there because a times a equals our a squared. And then we have our 2 and our 8. The last thing we need to do is figure out the signs of our problem. If this is positive, that means they're either both negative or they're both positive. Okay, and how we know if they're both, which one it is, if they're positive or negative, is what the sign of this number is. So since that one is positive and it's not a subtraction sign, that means they are both going to be positive in this case. Okay, so now, and then you're done. That was it. Let's see. I'm going to do the last one. Let's look at the last one. So again, I'm going to list the factors of 18. So 1 times 18, 2 times 9, 3 times 6, and I believe that's all of them. Yes, it is. Now I'm just going to look through which ones combine to make 3. So we've got 1 and 18 is not going to work. That's 17 and 19. 2 and 9 is 7 and 11, 7 or 11, and then 3 and 6 is, 3 or, no, it's just 3. No, 3 or 9. Duh. Got to add them too. So here's our answer. So again, I'm going to set it up. I have x, x. Again, you always want to do this part, right? This is almost always the same. It's always going to look like this. It's always going to have those two sets of parentheses. As long as our leading variable only doesn't have a coefficient of anything other than 1, it's just going to be x and x, or b and b, or y and y, or whatever we have. And then at that point, we just need to figure out the signs and the numbers. Well, we know the numbers now. So 3 and 6, doesn't matter where I put them. When this is negative, so like with the first problem, when it's positive, it means they're both the same sign. When it's negative, that means they are different signs. So one of these is positive and one of these is negative. The first problem, we had to figure out whether they were both positive or both negative. Here we need to figure out, since we have both signs, we need to figure out which one's positive and which one's negative. This tells us the sign of the bigger number. So just looking at 3 and 6, before we give them positives and negatives, 6 is the bigger number. So 6 will be the negative and 3 will be the positive. Alrighty, moving on. So you guys, since this, in the notes, you guys should give these a shot, pause the video, and then you can check back. And then I'm going to go over, I think I'm going to do 5 and 6. Okay, so here we go. 80. So the bigger the numbers they get, the longer the list of factors you have. Can be a little annoying, but sometimes you can just recognize what the factor pair that you need to use is, and that's totally fine. You don't need to do this every time, but I just think it's a good strategy. So 2 and 41 and 80, those are not going to work. We need numbers that are going to be close together because that 2 is small. Let's see, 3 doesn't go in. 4 times 20, 8 times 10, and I think we're good to go. The closest ones are these two, and they are going to make 2. So let's set up what we know is going to be there. My W's look not great, but that's all right. One of these is going to be 8. One of these is going to be 10. we have a subtraction sign. That's a terrible arrow. We have a subtraction sign here. So that means we have a positive number and a negative number, so we just need to figure out which one is which. Again, this tells us the sign of the bigger number. So we have 8 and 10. That means the 10 is the positive sign, and the 8 is the subtraction sign. Cool. On to the next one. 24, just going to list them out again. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So we're looking for 14. This one's not going to do it. 2 plus 12 is 14. So there we go. We found it. It is this one. Set up our equation, or not our equation, our binomials. What we know for sure is going to be there every single time. Our parentheses and our variable. I'm going to plug in my 2 and my 12 now. Okay. Here we go again. That's a positive sign, which means they are both the same sign. A negative times a negative is a positive. A positive times a positive is a positive. So they're both the same sign. This tells us which sign that is, so that means they are both negative. Alrighty, let's keep going. So this is factoring a difference of 2 perfect squares. There's a few ways to do these problems, and I will show you, well, the 2 ways that I use. So the first way is I just find the square root of both of these numbers. Okay, the square root of x squared is just x, and the square root of 49 is 7. Well, plus or minus 7. So we have x, plus 7, and x minus 7. And that's it, and you're done. The other way to do this is to look at it as the problems we were doing earlier, like a trinomial, where it's, you know what, this is not the best example for this one. I'll do this one. So we look at it like it's a trinomial like we were doing earlier, where the middle term that we're missing would be 0y minus 144. Okay. This could be a positive too. That doesn't matter because it's just 0. Adding by 0 and subtracting by 0 is the same thing. So at this point I would list the same ones. 2 and 72, 4, 5, 6. Let's see. 6 does go into it. Oops. 6 and 24, 9 and 16, 12 and 12. So we're looking for the ones when you combine them, they make 0. Well, that's always going to be when when it's the same number. It's the only way to get 0 that way is by subtracting. So there they are. This is a subtraction sign, so that means they're opposite signs. So we have y plus 12, y minus 12. So again, this helps. Doing it this way, takes a little bit longer, but it, for some people it might help you realize that we're doing the same process as we were up here. We just don't have a middle term. Our middle term is 0, so they're combining to get 0. Whereas this one, you just find the square roots, and this is the format that you're going to have every single time. X plus the number, and then x minus the number. So I'm going to do one more. So the square root of g squared is g. Square root of 25 is 5. We're going to have a positive and a negative one, so not x, g. G plus 5, g minus 5. Greatest common factor. So with the greatest common factor, first you need to find the greatest common factor that are coefficients. So what's the biggest number that divides evenly into 6 and 8? That's going to be 2. And then what's the most variables that you can pull out of both of those? We can't divide x by x squared. That's going to leave us with a x in the denominator. But we can take an x out of both of them. It's always going to be the lowest exponent is how many you pull out. So in this case, it's 1, so it's just 1x. Then you're going to divide both of these by 2x. You put your greatest common factor on the outside of these parentheses. 6 divided by 2 is 3, x squared divided by x is x, minus 8 divided by 2 is 4, and then x divided by x is 1, so there's nothing. And then that would be our answer. Let's see. I'm going to do number 12, and then 13 and 14 will be you guys. So again, the greatest common factor here of my coefficients, if the leading coefficient is negative, you're going to want to pull that negative out. So biggest number that goes into 15 and 10 is going to be 5. And then the lowest exponent is squared, so it's going to be a squared. Divide both of these by 5a squared, negative 5a squared, and we get negative 5a squared on the outside. Negative 15 divided by negative 5 is 3. A cubed divided by a squared is just a. Minus, the sign's going to switch because 10 divided by negative 5 is going to give us negative 2. A squared divided by a squared, anything divided by itself is 1. So we are done with that problem now. All right, next page, knocking it out. Here's plotting points on a graph. This over here tells us the quadrant that we're in, so that's the first quadrant. And this tells us the signs of x coordinate, and this one is the sign of the y coordinate. Okay. So, a refresher, x moves horizontally, y moves vertically. So my first point, negative 2, 7, we're going to go left 1, 2, and then up 1, 2, 3, 4, 5, 6, 7. So there is 15. Number 16 is 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. That's 16. 17, we've got 5, negative 3, 1, 2, 3, 4, 5, and then down 1, 2, 3, 17. 18 is negative 2, negative 5, 1, 2, left, and then down 1, 2, 3, 4, 5. I didn't mention it earlier, but for x values, positives go to the right, negatives go to the left. For y values, positives go up, negatives go down. Remember, we're always going to do x first and then y. So 19 is 4. Whoops. Nineteen is 4, 0. 1, 2, 3, 4. And 0 up or down. 20 is 0 left and right. And then down 4, 1, 2, 3, 4. So there's 20. Negative, or 21 is left 4, 1, 2, 3, 4, 0 up or down. So 21. And then last we have 20, which is going to be 0 left or right, but 4 up, 1, 2, 3, 4. 22. The last four want us to decide which quadrant each point is. So number 13 or number 15 is right here, and if we look up, that is quadrant 2. Hopefully you get these memorized, which quadrants are which, 1, 2, 3, or 4. It's pretty straightforward, pretty simple. All you need to do is find one and then work counterclockwise from there. 18 is right here. So if this is 2 up here, that means counterclockwise. This is 3 down here. Number 17 is right here. Again, moving counterclockwise. If this one is 3, this one is going to be 4. And then last is 16, which is in the same quadrant as 17, so that is going to be quadrant 4.